Welcome back to the Deep Dive. Today we're taking a really fascinating and very specific look behind the scenes.
A really specific one.
Yeah, into an industry you probably interact with constantly. We're talking about the production of liquid tinctures.
Right. And you should forget that, that simple image of someone just steeping herbs in a jar.
Not at all what this is.
No. What we're exploring is industrial scale, high precision manufacturing. It's all governed by really strict scientific rules and just extreme time pressure.
And that's our mission today, really, to unpack this manufacturer's specific 6-step procedure. We want to understand not just what they do, but, why they do it. We'll get into why speed is so critical and why this one thing, solubility, basically rules the entire process.
And for you, the learner, this is really important. The source makes it clear right away why tinctures are such a potent way to deliver ingredients.
Okay.
You get increased absorption, which often means higher potency compared to, say, a pill. Plus, they're convenient, and you can create some truly unique custom formulas.
And the scale of this whole operation is, it's just immense. The manufacturer notes that the minimum order to even get in the game is 5,000 units.
5,000.
Or 100 gallons if you're buying in bulk. You just don't hit those numbers without a very, very sophisticated operation.
So let's start right there, right at the beginning of that operation where the raw plants come in from the field.
When that raw material arrives, it starts with step 1, cleaning.
It sounds basic.
It sounds so rudimentary, but it's absolutely foundational. Every last bit of foreign contaminant, we're talking soil, little insects, anything, it has to be completely removed before those plants go anywhere else.
And the second that cleaning is done, the material moves straight into step 2, analysis and verification.
You can't just assume it's clean.
You can't. Samples go immediately to their labs, either in-house or third-party, and this is where they do a kind of chemical fingerprinting.
Or what exactly?
2 things. 1, to verify that all those contaminants are actually gone, and 2, to make sure the plant material itself meets the quality and the chemical profile that they need.
And the tech here is what really separates, the pros from the amateurs. They rely on 3 big testing methods. High-performance liquid chromatography.
HPLC.
HPLC, right. Then gas chromatography, or GC, and thin-layer chromatography, TLC.
And you really do need all 3 because they serve different purposes. It's fascinating to understand the trade-off, especially between GC and HPLC.
Okay.
So gas chromatography works great for analyzing simpler, lighter organic substances. Very effective for that.
But with natural products, things are never simple, right? You've got these really complex molecular structures.
Precisely. And for those, high-performance liquid chromatography is what the source calls the obvious choice.
Quite obvious.
The reason is absolutely critical. A lot of natural plant compounds are thermally unstable.
Meaning they don't like heat.
Exactly. If you try to run them through the high heat needed for gas chromatography, the very active components you're trying to measure could be destroyed or altered. HPLC lets you analyze these sensitive structures without damaging them, so you know the analysis is accurate.
So choosing the wrong test doesn't just give you a bad reading. It literally destroys the evidence.
That's a great way to put it, yeah.
And all of that quality control has to happen before they even think about processing thousands of liters of this stuff. Which brings us to step 3, selecting the extraction agent and the preservative.
And in this world, for tinctures, one agent just dominates the field, ethanol, potable alcohol. The source calls it the best extracting agent and preservative, and its dual function is really why.
It's doing 2 jobs at once. It's the solvent and it's the shelf life guard.
Absolutely. Think about the plant cells. The alcohol gets inside and absorbs both the water-soluble and the fat-soluble stuff, so you're maximizing your yield.
Right.
And at the same time, because it's alcohol, it's killing off any bacteria that might be left. That's what guarantees the product is safe and durable as long as you take the right dose.
So ethanol is the linchpin. It handles all the chemistry and the shelf life in one go. Okay, so the plants are clean, they're verified, the agent is ready. Now we pivot to the really high stakes part.
The race against time.
The race against time.
Yeah.
Step 4 is where things become just a whirlwind. Speed is everything.
The source really emphasizes this. Once the plants get delivered from the field, they have to be processed within a critical 24-hour window.
24 hours. That's a staggering deadline when you're dealing with tons of material. Why so tight?
It's all about efficacy. You have to lock in that chemical profile of the fresh plant before natural decomposition starts to degrade the active compounds you want.
So that deadline dictates everything, their whole infrastructure.
Everything. How close their facilities are to the farms, how
Yeah.
quickly their equipment can be cycled. It's a huge logistical challenge.
So if they miss that 24-hour window, it's not just a delay. They're actually losing potency.
They're losing potency, and they might have to throw out the whole batch. It's a massive financial risk. Now, they mention some rare exceptions, like for long-distance transport, maybe 48 hours, but that requires intense, extra quality controls.
I see. So what does that look like on the factory floor?
Well, the volume demands speed. The fresh plants are crushed by machine, they move along conveyors, and then they're dropped into these huge maceration tanks.
How big are we talking?
1,000 liters,
Huh.
sometimes bigger.
Wow. And once the crushed plant is in the tank, they add the water and the alcohol to create what they call the macerate.
Right. And this starts the maceration phase. And this is not just a quick soak. The source is very clear. This is a scientific process. The plant material is infused for a precisely specified time.
And they're agitating it.
Right.
Mixing it.
Yes, with a defined frequency and duration of agitation. It's all calculated.
It sounds like the R&D department is just constantly tweaking these recipes.
They are. The R&D team runs these lengthy tests, sometimes for weeks on a new ingredient, just to find the perfect maceration time and the exact alcohol content.
All that just to get the maximum possible extraction.
Without damaging the product, it's an enormous investment for every single new formula they develop.
So once that super precise maceration time is up, they move to step 5.
Separating and recycling the residue.
Okay, so the liquid, the tincture, is pressed out from the leftover solid plant material.
And that leftover solid stuff has its own name. It's called the marc.
I have to say, this was one of the most surprising details for me. At this kind of industrial scale, you'd think that spent plant material would be a huge waste problem,
You would.
but they actually recycle the marc.
It's a great example of, industrial resource management. This huge volume of marc is composted. They often mix it with mushroom or horse manure to create this really useful, nutrient-rich fertilizer.
And if they can't compost it,
Then the material gets sent to a biogas facility. They convert it into energy. So the entire circle, from the plant in the field to the final product, it's all considered.
that's a true closed-loop system. Amazing. Okay, so let's move from the extraction to the final frontier here. Custom formulation, solubility, and all the limits of working with liquids. This is step 6.
Right. And this is the stage where chemistry is just the ultimate gatekeeper. It determines what a brand can actually put into their product.
And a huge concept here is potency.
It is. The source is explicit. The amount of active ingredients you can add depends on the method. Extracting herbs gives you a way more potent final product than just using dry powders.
And why is that? Why is extraction so much better than just dumping powder in a liquid?
It all comes down to one word: solubility. Dry powders have really severe limits on how much you can dissolve in a liquid base before it just, settles at the bottom or crystallizes.
Right.
Extraction pulls those active compounds out of the plant structure and puts them directly into the solution. It completely bypasses the solubility limits you'd have with a dry concentrate.
And this brings us to what feels like the non-negotiable core rule of liquid formulation.
It really is. The manufacturer issues a very clear warning here. It is not recommended to mix water-soluble ingredients and oil-soluble ingredients in one product.
It's basically forbidden.
It's practically forbidden, yeah. The chemistry just won't allow for a stable, long-term product.
So if you're using a water, glycerin, or alcohol base, you have to use water-soluble stuff.
Mm-hmm.
And if you're using a carrier oil, you have to stick to oil-soluble stuff. If you break that rule, what happens? What does the consumer see?
You get instability. The product will separate, the ingredients will fall out of suspension, and you lose all uniformity. That means the dose in your first dropper is different from the dose in your last.
So it's an inconsistency and a potential safety issue.
Absolutely. And to make it even more complex, there's the physical nature of the ingredients. The source notes that the bulk density of an ingredient absolutely changes the solubility.
Okay, bulk density. That's a subtle point.
It's subtle, but it's critical. Bulk density is basically how much space an ingredient takes up for its weight. And that density determines how well it will dissolve and stay suspended in the liquid. You can't just assume two different dry powders will behave the same way in water, even if they have the same weight.
And beyond all that strict chemistry, there are also the aesthetic and sensory challenges. taste, and smell.
Right. Liquids are unforgiving. It's not like a capsule where everything is hidden. In a tincture, you taste and smell everything.
So flavoring can be tough.
Extremely limited, depending on the herbal ingredients. And getting a perfectly clear liquid, it's often impossible if you have a high concentration of herbal extracts.
And what about bad smells?
That's mentioned as the most difficult challenge, overcoming naturally foul-smelling ingredients. You can't mask everything.
Mm-hmm.
Yeah, that's often a major consultation with the client. The account executive has to manage expectations or try to find a really complex and usually expensive natural flavoring solution to make the product palatable. It's never an easy fix.
And then finally, we get to the actual bottle, the consumer interface. Step 6, filling and packaging.
Right. And most tinctures, as you know, rely on the good old dropper cap.
Why is that still the standard?
Because it's still the most accurate and repeatable way to deliver those small, potent amounts of liquid.
Makes sense. And the standard sizes are what? 1, 2, and 4 ounce bottles.
That's right. 1, 2, and 4 ounce in either glass or plastic.
Now, it's worth pointing out that this expertise in liquids isn't their only business.
No, not at all.
They provide a full range of formats: capsules, chewable tablets, soft gels, gummies, powders. It lets brands build out complete wellness lines.
And that service model is designed to help clients navigate all the complexity we've been talking about. They promise what they call superior service through these dedicated account executives.
And it's more than just customer support.
Much more. They position themselves as experts who solve the problem for you, whether that problem is hitting the 24-hour window, figuring out a bulk density issue, or dealing with a supply chain crisis.
That hands-on part is crucial because this industry is, of course, heavily regulated.
Oh, absolutely. When safety and quality are on the line, verification is everything. The source lists this huge array of certifications they hold.
Like what?
Things like GMP, NSF, NPA, TGA, SQF, USDA Organic, Kosher, Halal. It's a really comprehensive list.
But there's a catch.
There is, and it's a key regulatory takeaway. Those certifications can vary by facility or even by product type, so a client has to verify the specific compliance for their exact batch at their specific location. It's not just a blanket guarantee, it's a constantly managed system.
Okay, so let's bring this all back together. We learned the process starts with just extreme cleaning. Then it moves right into this rigorous lab testing, comparing methods like HPLC and GC to protect those heat-sensitive compounds. We saw how ethanol acts as this, chemical engine extracting and preserving at the same time.
And we saw how the whole operation is ruled by that 24-hour ticking clock. Then we followed the mark from being industrial residue to becoming useful fertilizer or even energy.
And most critically, we saw that the entire formulation, everything, hinges on the unforgiving rules of solubility and bulk density.
Right. It really transforms that little bottle on your shelf, doesn't it? It goes from being a simple extract to a product of some serious high-tech chemical and logistical mastery.
It really does. So here's a final provocative thought for you to consider. The source material is very clear that the most potent quantity of active material comes from extracting herbs, not just from using dry powders because of those solubility limits.
Yeah.
So given that limitation, how significantly does choosing an extraction-based tincture potentially change the effective dose and the efficacy you get compared to a liquid supplement that's just made with powder?
That gap, that difference between what can dissolve versus what is actively extracted, that's the key question you should be asking yourself the next time you're comparing product labels and thinking about which one actually works.
Thanks for diving in with us. We'll catch you next time.